So what I'm going to show you how to use here are something called global connectors. And what a global connector is a way to assert there are relationships between experiments that aren't simply, oh, these experiments share the same global value. And so as an example, I'm going to use a Van 't Hoff analysis where we've measured the same binding reaction as a function of temperature. And from a Van 't Hoff analysis, we would expect to see the binding constant vary in a defined way while the enthalpy remains fixed as a function of temperature. Okay, so to do that, what we're going to do is add a variety of experiments taken as a function of temperature. So we're going to add a 5-degree C experiment, and then we're going to add experiments that we measured as a function of temperature. So we're going to add an experiment at 17 degrees and a final experiment at 30 degrees. Okay, so we have the same binding reaction measured as a function of temperature, and now I'm going to show how you can fit a Van 't Hoff model to this. Okay, so what we're interested in is how the binding constant varies as a function of temperature in a Van 't Hoff way. And to get at this, we're going to go to the global linker, and instead of just saying add a global, we're going to add a connector. And then we have a variety of different connectors to choose from. So we can do a Van 't Hoff connector in this case. And what this is going to bring up is information that's important for that, in this case the reference temperature, and then this method called connector K, which is the Van 't Hoff, the binding constant you would calculate using a Van 't Hoff model, or in this case the enthalpy you would calculate using a Van 't Hoff model. I'm going to select the K because I was linking this to the global K variable there. So you'll notice I have now, with my added this connector K, I can no longer mess around with the binding constant itself because that's no longer a fit parameter. Instead, what I'm going to do is add these new fit parameters, which is the binding constant at the reference temperature and the Van 't Hoff enthalpy. Those are my new fit parameters that can then be used to calculate my binding temperature there. Okay. We had the other thing that gets spit out by the Van 't Hoff model is this connector enthalpy. So that's now the enthalpy for that binding reaction as a function of temperature. Last thing that's happened is you'll notice down here this temperature appeared. So this is actually the exact temperature of the experiment extracted from the ITC output file. If you do different types of connectors, say you do that num protons connector, this will appear and will have you need to actually type in, say, the ionization enthalpy. But temperature is already in our data, so we don't have to type it in manually. Okay, so what we said is that binding constant of each experiment is determined by this Van 't Hoff connector, and the enthalpy is determined by this Van 't Hoff connector. Now we're going to start adding all of our experiments to this data set, so we can go here and select our connector K for that, for the 17-degree experiment, and our enthalpy as well. Notice the temperature is 17 degrees, and we're going to repeat this for the 30-degree experiment. We're going to add the connector K and the connector enthalpy for our 30-degree experiment. Okay, once we've built those sets of connections, we can then do our fit, and we can now back out, in this case, our Van 't Hoff enthalpy and our binding constant at a reference temperature for this experiment. Just like before, we get exactly the same kinds of outputs. We get our actual fit and residuals, fit statistics, fit parameters, a corner plot that shows how these different coefficients are related to each other, as well as uncertainty on all of our fit parameters. So you can imagine adding more data to do this better. You can imagine different kinds of global connectors. If you're interested in implementing your own global connector, you can actually learn how to do that using a few lines of Python over in the actual underlying pytc API. You can even submit that so that we can include that in future releases of the software. So hopefully now you know how to do Van 't Hoff and other kinds of global connector fits using pytc.